All right, let's dive right in. Today, we're talking about a really cool shift in machine learning. It's all about moving beyond just looking at individual data points, and instead unlocking the power of the relationships between them.
You know that feeling, right? Your movie app suggests the perfect film, or a social network somehow finds a friend you haven't seen in years. It feels like magic, but it's not. The secret, a lot of the time, is in looking at data not as a flat table, but as this rich, interconnected web.
So before we get into the whole graph thing, let's do a super quick refresher. The basic idea of machine learning is pretty straightforward. You train a model on some data you already have, so it can make smart predictions about new data that comes in. But how it learns really depends on the kind of data you're working with.
There are a few main flavors of machine learning. With supervised learning, you've got nicely labeled data, and you use it to make predictions. Then there's unsupervised learning, where you just throw a bunch of unlabeled data at it and say, find some interesting patterns for me. And then there's the really powerful middle ground, semi-supervised learning. That's where you use just a few known labels to figure out a whole massive unlabeled data set. Keep that one in mind, because it's going to be a big deal in a minute.
Okay, so if we have all these cool techniques, why do we need to mess with how we store our data? I mean, for anyone who's ever worked with a relational database, you know that tables are king. They're organized, they're efficient, they just work. But what happens when the most important piece of your data isn't the stuff in the rows, but the connections between them?
So this is the classic way to do it, right? You've got a table for your users and another table just for friendships. You link them up with foreign keys. If you want to see who's friends with who, you run a join. Easy enough. But what if you want to find friends of friends or friends of friends of friends of friends?
And that quote just hits the nail on the head. Every one of those hops, from a friend to their friend, that's another really expensive join operation. If you want to follow a long chain of connections, your query can get super slow and incredibly complex. The way your data is stored is actually fighting against the very question you're trying to ask.
This is where we need to kind of flip our thinking. What if, instead of trying to cram relationship data into tables, we used a data structure that makes those relationships the star of the show? That's a graph.
It all starts with the basics. You take your individual things, your people, your products, your movies, and you represent them as vertices, or you might hear them called nodes. You can pretty much think of these as the rows from our old database table.
Now, here's the magic. Instead of needing a whole separate table and a join just to say two people are friends, we just draw a line between them, a connection. That's called an edge. Suddenly, the relationship isn't an afterthought you have to calculate. It's a first-class citizen in your data model.
And it gets even cooler. We can store information or properties directly on both the nodes and the edges. So a person's node can have properties like name and age, but the edge connecting two people can also have properties like the type of relationship, maybe is friends with or works with, or even a weight, like how many messages they've sent each other.
Okay, so that's the theory, but what can we actually do with this? Now that we're thinking in terms of connections, what kind of new and powerful questions can we start to answer?
Well, let's go all the way back to the beginning. Remember that movie app that just knows you'll love that quirky indie film? The answer is all about the connections between you, other people, and all the movies you've all watched and rated.
A really common way to model this is with something called a bipartite graph. Just picture two big groups of nodes. One group is all of your users, and the other group is all of the movies. An edge only connects a user to a movie they've actually rated. A machine learning algorithm can then look at this giant web of connections and start predicting the missing links, a potential edge between you and a movie you haven't seen but are probably going to love. And once you start looking, you see this graph-centric approach everywhere. Trying to find the shortest route on a map? That's a classic graph problem. Uncovering complex financial fraud rings? You literally follow the money through a graph of transactions. Figuring out which web pages are the most important? Yep, that's what Google's original PageRank algorithm was all about. It's all about analyzing the structure of the connections.
Now let's talk about another awesome scenario. Remember that semi-supervised learning idea? It's absolutely perfect for the real world, where labeling all of your data is just way too expensive or would take forever. So how can graphs help us out here?
So picture a huge network, thousands, maybe millions of nodes, but we only know the classification for a tiny handful of them. Let's say one is blue and another is red. Everything else is a total mystery. If this were all on a table, those two little labels wouldn't help us much.
But in a graph, we can do something called label propagation. The idea is super intuitive. Things are probably similar to their neighbors, right?
So the algorithm literally spreads the known labels outward through the connections. It's like color bleeding through paper. The nodes connected to the blue node start to turn blue, the ones near the red node turn red, and pretty soon you've classified the entire network based on just those two starting points. It's incredibly efficient.
So we've covered a lot of ground here. When you boil it all down, what's the one big idea you should really walk away with?
It's really this. By making connections a core part of the data itself, we can ask completely new types of questions. We can analyze influence, we can find communities, we can spot hidden patterns in a way that's so much more natural and powerful than just trying to connect the dots across a bunch of tables.
And that's really the question I want to leave you with. Think about your own data for a second, whether it's customer behavior or network traffic or anything else. What crucial connections, what hidden relationships might you be missing just because you're only looking at the rows and not the incredible web they create?
All right, that's it for this one. If you found this useful, you know what to do. Go ahead and like, share, and subscribe for more deep dives. Thanks for watching.